Hello guys, welcome to Maths with EduKartik, and today we are going to start with a new part of exercise 6.2 triangles, which is part 2. In the previous part of this exercise we have done first 6 questions and now we'll do the last 4 questions of this exercise. These are mainly dependent on proof of the theorems which we have read in the class 9th. First question, or you can say the 7th question of the exercise, which is first question of this video. Here itself says proved in class 9. Here we have to prove converse of midpoint theorem, which says a line drawn from the midpoint of any one side of a triangle means midpoint of AB is D. So when we draw a line from point D parallel to the second side BC will bisect the third side, means we have to prove that AE equal to EC. Okay, how we'll do that? We have to prove it using theorem 6.1, or you can say basic proportionality theorem. So, what is BPT theorem? If two triangles are similar to each other, then ratio of their sides will be equal. Or it is also if a line drawn parallel to the second side will divide the both sides in same ratio. Okay, so in triangle A B C, DE parallel to BC, DE parallel to BC. So we'll say that by BPT, basic proportionality theorem, by BPT we can say that AD upon DB equal to AE upon EC. AD upon DB equal to AE upon EC. Now we know that AD and DB are equal to each other. How equal? Because D is the midpoint. D is midpoint of AB. D is midpoint of AB. So AD equal to DB. So now we can write that AD upon AD equal to AE upon EC. Because these are equal, so we can name them same. So AD can cancelled by AD. So we will have 1 equal to AE upon EC. So when we send it that side, it will become EC equal to AE. It means that E is midpoint. Now we had to prove that E is midpoint. If E will be midpoint, then AC is getting bisected. Hence, proved. Yes, has proved. Now next question. So here in this question, we have to prove the midpoint theorem using theorem 6.2, means using converse of BPT. So line joining the midpoints of any two sides of a triangle is parallel to third side and half of it, but half of it is not mentioned. So line joining the midpoints of any two sides of a triangle. So it tells that D and E are mid points. D and E are midpoints. So if D and E are midpoints, then AD upon DB equal to 1. AD upon DB equal to 1. And we have to prove this side parallel to this side, DE parallel to BC. and AE upon EC equal to 1. AE upon EC equal to 1. So 1 equal to 1. This is equation 1. This is equation 2. So since RHS is equal, so LHS will also be equal by 1 and 2. We can say AD upon DB equal to AE upon EC. If two lines are getting divided in same ratio, then the line dividing them is parallel to the other side. Means these two lines are getting divided in same ratios. So we can say that this is parallel to this. AD upon DB equal to AE upon EC. Means this line is parallel to this line. Therefore, DE parallel to BC by converse of BPT. Easy. Now we'll come to our next question. Here, ABCD is a trapezium. AB parallel to DC and diagonals intersect each other at point O. We have to show that AO upon BO equal to CO upon DO. Here, construction is that we'll draw a line EO. Draw a line EO parallel to DC. We'll draw a line EO which is parallel to DC. Okay. Now, we'll take triangle ADC. In triangle ADC. In triangle ADC, here EO is parallel to DC, so AE upon ED equal to AO upon OC. AE upon ED equal to AO upon OC by BPT. This will be equation 1. Now we'll use the second triangle. In triangle ABC, here we know that EO is parallel to DC, but it is given that AB is also parallel to DC, so EO will be parallel to AB. EO parallel to AB. EO is parallel to AB. So here also we will use BPT. AE upon ED equal to AE upon ED equal to BO upon OD. OD. Now this will be equation 2. From 1 and 2, we'll use equations 1 and 2. Here if you notice, AE upon ED, AE upon ED, our LHS is equal. Our LHS is equal. Both LHS. So RHS will also be equal. AO upon OC equal to BO upon OD. AO upon OC equal to BO upon OD. Okay, now OB or BO both are equal. AO or OC both are same. You can name it AO or OC, it's your choice. So since it is given AO, so we'll keep it AO. But here OC is not given, CO is given. So what we'll do, we'll send both these both in opposite direction. AO upon BO equal to CO upon DO. AO upon BO equals to CO upon DO. It will not come itself. You'll have to firstly derive an equation, then you have to name it yourself and convert it according to the given in question. So here AO upon BO was given, but we got AO upon CO equal to BO upon DO. So we sent OC that side and OB came this side. So AO upon BO equal to CO upon DO. Hence proved. Now it is the last question of our video. Here we have been given AO upon C equal to BO upon DO. But we have to show that ABCD is a trapezium. How we will show it? ABCD is trapezium. To show this, we can say that AB parallel to CD. If we prove this, then we can say that trapezium. It is a trapezium. This quadrilateral is trapezium. Because trapezium is a quadrilateral in which two sides are parallel, but other two sides are not parallel to each other. So here AO upon CO equal to BO upon DO. AO upon CO equal to BO upon DO. Now again we drew EO parallel to AB. Draw EO parallel to AB. EO is parallel to AB. Now in triangle ABD, ABD. In triangle ABD, EO is parallel to AB. Okay, so AO upon CO equal to BO upon DO was given, and AE upon ED equal to BO upon OD. AE upon ED equal to BO upon OD. See, this is equation, not this. This one is equation 1, this one is equation 2. Now this RHS is equal. Both RHS are equal to each other. So by 1 and 2, by 1 and 2, we can say that AO upon OC equal to AE upon ED. Now A upon OC equal to AE upon ED. We have got this. This will be equation 3. Now which triangle we'll use? We'll use this triangle ACD. In triangle ACD, AO upon OC equal to AE upon ED equal to AE upon ED. Now by converse of BPT, by converse of BPT, by converse of BPT, we can say that these two sides are dividing each other in the same ratio. So these lines will be parallel, means EO parallel to CD. EO will be parallel to CD, and EO was also parallel to AB, but EO was also parallel to AB. So AB parallel to CD. Therefore, AB CD is a trapezium. See, now what I did, EO was parallel to CD and EO was also parallel to AB because we have drawn it by construction here. So this was equation 4. Equation 4, and we got EO was parallel to AB. So LHS are equal, so RHS will also be equal, or LHS are parallel, so RHS will also be parallel. So we got AB parallel to CD. If these both sides are parallel, then it is a trapezium, as I told you in the starting. So hence we got our answer. And here our exercise ends. Now in the next video, we'll start with a new exercise. Till then, bye bye.